Hello guys, welcome back to my channel. In today's video it's about unsigned multiplication with assembly. Here we have several variables for bytes, word, double word and quad words. Also double quad words. So let's see the instructions for multiplying. So basically moving into IO register the first variable, and then in this particular case for squaring the variable it's just using only the source by itself multiplying, and then moving into the result the AX register. So here I made simple list, and when we use move instruction, this is the source, and when we store data inside these registers, the result is like this. The higher part and the lower part is in that order, and here it's just moving for the bigger result, just moving to the address for storing. In that case this is the word, and it needs to be in double word, so the hyper result is to the next 2 bytes and the lower part is the first 2 bytes. In this case the answer 2, let's see here, the answer 2 double word, yeah, and the rest is as follows. So here 4 bytes for double word to fit in quad word, and quad word into double quad word for next 8 bytes. Let's see the result. Here is the same assembly as previous one, just for the debugging options using this format. For the executable I use this format, and the object file is that one. So linkage, and let's debug it. So on line 33 and breakpoint, starting, and let's watch the RAX register and that register. So 42, yeah, 42, and then just multiplying IO, so 42 times 42 is this number, then storing AX into this variable, then moving B num A inside IO, and the new value is that one. Let's see. So here is the multiplication of this one and this one, and the result is 3066. Next, storing it inside the word answer one over here in double word, and here we have the 2 register, the hyper one RDX and the lower part of RDX, this one of the register, just with bigger values. It's important to use the correct offset and addressing of each variable and to define the size, and must match with the registers for 16, 32, 64 and 128 bits to match this one for the unsigned multiplication. If I missed something, let me know in the comments below. That's all for this video. Until next time, bye bye.